School people, and welcome. In this video, we are talking about graphing discrete exponential functions. So we already were taught what an exponential function is. We already did examples of continuous exponential functions, and now we're doing a discrete. So the difference between continuous and discrete, we don't connect the points. Continuous, we do connect the points. Discrete, we don't. And now for discrete, the reason we don't connect the points is because of this right here. This is the given domain. So this domain is given. And because it is given, we can only use those values. We cannot use any other value at all. For whatever reason, we can't do it. So how are we going to graph this? We're basically going to do the exact same thing, except now we don't get to choose our values. The values have been chosen for us. So let's go ahead and start. We're going to make that really big T-chart. On one side, here's going to be your X values. Here's going to be your work. And then here's going to be your Y values. And basically, we're just having a relationship between our input, our domain, and our output, our Y values. For our domain, they give us a -1, 0, 1, and 2. This is what they give us. We cannot use any other numbers. If I wanted to use 3, I cannot. If I wanted to use 1/2, I cannot. I can only use these values. For my work section, I'm going to copy down my formula. My formula is 2/3 X. In this case, I'm going to omit the X. I'm just going to write 2/3 because our X value is what we are given. That's our domain. So that's going to be my -1, 0, 1, and 2. -1, 0, and I'm going to put them in parentheses, 1 and 2. So here it is. So how do we solve something like this? Well, we have to go back to what does it mean to have an exponent? What does it mean to have a negative exponent? What does it mean to have a positive exponent? What is an exponent? So for a negative exponent, what that means is if you have a fraction, then you skip step number 1. If you don't have a fraction, you have to make a fraction. So we have a fraction, you're going to flip that fraction. So now the 3 is on top, 2 is on the bottom. You're going to remove that negative, so I no longer have a negative, and I'm just going to keep whatever number that is. That means that I'm going to write my base that many times. So if this tells me I have the base of 3/2 and my exponent that I circled is 1, then I'm just going to write this 1 time, which is 3/2. And that's it. We don't have to add or subtract anything in this example. So that is my Y value. My Y value is 3/2. So when I input -1, my output is 3/2. Now let's try one more time. This one I'm doing a happy dance for because anything to the 0 power is 1. So this is just 1. So my input was 0, my output is 1. Now this one here, again, positive exponent of 1, which tells me I just write my base 1 time. So my base is 2/3. My exponent is 1, that's it, 2/3. And now for the last one, it's a positive exponent. So it's a positive exponent, and then we have our base. So our base is 2/3. Our exponent is 2. So 2/3, we are writing it twice. So that means exponent is 2. So the exponent is 2, so that means I'm writing it twice. 2/3 times 2/3. So what is 2 times 2? 2 times 2 is 4. What is 3 times 3? 3 times 3 is 9. So for this output, I have 4/9. So my input is -1. My output is 3/2. My input is 0. My output is 1. My input is 1. My output is 2/3. My input is 2. My output is 4/9. Now, if it's easier for you to do decimals, that's fine to graph, but if you are given a fraction, you want to keep it in terms of a fraction. All right, let's go ahead and graph this. It's a little more difficult to see where our lines are, so I'm just going to draw it here. So that's our x-intercept. Here's our y-intercept. So we have -1 and 2/3. So 2/3 is about 1 1/2. excuse me, 3/2 is 1.5, not 2/3. So 3/2 is about 1.5. And then let's figure out what the other ones are. Let's use a calculator. And so let's see what 2/3 is. 2/3 is about 0.67-ish. Oh, I wrote it in the wrong place. 0.67-ish. And then 4/9, that's about 0.44. And it's sometimes easier to graph because then you know how close it is to 1, how close it is not to 1. So let's do this one. -1 and 1.5, so 1.5 is here. 0 and 1, which is here. 2/3, which is 0.07. So 0.067, 0.67, let me say it correctly, is there. And then even smaller is here. Now we want to make sure we know what our asymptote is. Our asymptote is that number here. So notice that there's nothing there. Right here, let me move the paper. There's nothing there. So that means our k value, our asymptote, is 0, which means our asymptote, the line that we shall not cross, is this line right here. And you want to show it in a dotted line. So this is going to be a decreasing function because this b value is smaller than 1. So we're going to go downhill. So here it is, downhill. We're going to get super close to that line, but we're not going to cross it. Oh, you guys, shame on teacher. Did you guys see what I did? I connected my lines. No, no, no. Don't do that. Shame on teacher. I hope everyone's screaming at me. Why do we not connect the lines? Because this is a discrete graph. This is discrete. The domain is given, okay? Since the domain is given, we do not, I repeat, we do not connect the lines. The points, we leave them. We leave them as such, even though it might seem a little silly. We cannot connect it. So this is it. That's the graph. That's it. Don't connect the lines. Don't put more lines. Don't put more points. Whatever you have, that's what it has. It's discrete. They have given you everything that you need. Do not do more. Do not connect the lines if the domain is given. All right, beautiful people, that is it for our discrete example. As always, thank you so much for watching, and I hope you caught that mistake before I did, but I'm glad I did. All right, enjoy the rest of your day. Bye.